Hello everyone, today we're going to be talking about graphing absolute value functions. So first, just to learn a little bit more about absolute value functions, this is a function that contains an absolute value expression. And some key facts about it. First is that the parent function is f of x is equal to the absolute value of x. And when I say parent function, I'm basically just meaning the function in its most simplest form. So the most simplest form is if we just had the absolute value of x. And as we can see on the right-hand side of the graph is V-shaped and symmetric. And so when I say symmetric, that means that if I were to fold it in half, both ends would match. So I see here that it's symmetric about the x-axis because each point reflects over it. So here I see like this first point here, they're both 1 away from the x-axis. These 2 points are both 2 away from the x-axis, and so forth. And so we also have something called vertex form of an absolute value function, and that is f of x is equal to a times absolute value of x minus h plus k. And so here, when we have it written in this form, we see that the vertex is hk. And the axis of symmetry is the line x equals h. So for example, f of x is equal to the absolute value of x. If I were to write that in vertex form, this would be the same thing as x plus 0 plus 0. So the vertex here is 0, 0. And we see that in this graph right here, our vertex, which is basically the pointy part of the V shape in the graph, is at 0, 0. And something to point out here that might trip you up, and I see this a lot, is that your h in your vertex, you're going to take the opposite sign of what you see here. So I see here in the vertex form, I have minus h, but my vertex is actually a positive h. Okay, so you're always going to take the opposite sign of what you see here. So let's see some examples of identifying the vertex. So for each of these functions, 1 through 4, I'm going to identify the vertex of the absolute value function. So I'm going to go ahead and rewrite each of these so it looks like what I see up here, where I have an x minus h and a plus k. So here I have x plus 1, so I'm going to rewrite that to be x minus. And to do that, I have x minus a negative 1, minus 3. And now from here, I can identify the vertex. So I know my h is going to be whatever I'm subtracting. K is whatever is added or subtracted at the end. So that means that my vertex here is negative 1, negative 3. Okay, let's look at another one. So here I have f of x is equal to the absolute value of x minus 2 plus 4. So here I already have it in that same format of I'm subtracting something. So that means my h here is 2 because I'm subtracting 2. And my k is 4. So my answer here is negative 2, 4. Okay, now for this next one I have that f of x is equal to the absolute value of x plus 5. And I don't have anything added at the end. However, if there's nothing there, that's really the same thing as I am adding 0. And so that means here my h, which I want to change that to being subtracting. So x plus 5, same thing as subtracting a negative 5. So I find that my h here is going to be negative 5. My k is 0, so that means that my vertex is negative 5, 0. Okay, and then looking at this last one, I again want to rewrite it so it looks like my vertex form. Here I only have the absolute value of x in there, so I can rewrite this to be x minus 0, minus 7. So that means that my h is 0, my k is negative 7, so I get that my vertex is 0, -7. So we see here your h is just going to be the opposite of whatever you see inside of the absolute value. Your k is whatever is added or subtracted at the end. And again, this is your vertex. That's going to be where the two lines on either side of the absolute value meet.